stole my slide. That's good. One thing that you didn't mention is that in my spare time I do ballroom dancing, and that's actually a picture of me and my partner. So let's talk about HTML5. That's a new technology which is, not a standard that is set in stone. It's always developing, and it doesn't have a time frame when this one will be finished. So it has a lot of technologies which are incorporated into HTML5, and some of them were part of HTML5 and then sort of broke off and became their own things. They're listed on the list: cross-origin, resource sharing, cross-document messaging, web storage, iframe sandboxing, browser history management, geolocation, you name it, web workers, web sockets, all of that stuff. So I'm not going to talk about all of them. I'm going to talk about the first 4 because we only have 40 minutes. And we'll start with cross-origin resource sharing. So what is CORS? I have a better video here. There we go. So CORS is a way how you can control on the server which other server can access the information from a web page. So without the CORS, we have a web browser that sends a request to, say, digital.com, and the server responds with 200 OK, we load the page, everything is fine, right? Then the page is doing some processing and sends a request to another web server. So because we don't have CORS here, the other web server will not grant the request, right? It will prohibit any requests from another domain. But that's what developers want to do. And so there is a new technology that allows to configure which request can get access from another domain. So with the CORS, we're sending again the request to the example.com, and we specify the origin, right, where it comes from. On the example.com, we have a list of origins that are allowed to get requests from our server. So because digital.com is in the list, we respond with 200 OK, and we specify this header: access control allow origin. The browser gets it, says, yep, that's where the request came from. Request granted, we got the resource, right? So then if we have a third-party domain, a third-party iframe here that comes from maliciousAttacker.com that sends a request to example.com, the origin is not digital, so I need to pause that here. So the request is not granted. But if we set the access control allow origin to a star, which means any domain can access it, then we get the response back, and the malicious domain gets the data that was not intended for it, because it was listed as a star, as a wild card. So that's the problem with CORS, is that it's a great technology. It gives you the ability to send requests across the domains, but then if you don't configure it properly, stuff can happen. So what do we do to protect it? First thing is that you need to configure the access control allow origin properly. So you need to set the list of domains that can access your data if they're loaded from a web browser from a different domain, right? So don't use wildcards, and follow the principle list privilege, meaning that if you know that this website definitely needs access, then grant access. If you're not sure, like in this example, we specified www.example.com and then login.example.com. So we don't specify just starexample.com, saying that any subdomain on example.com can access it. So be very fine-grained and specify what exact subdomains can get the information. Why that happens, why would people just put a star instead of a specific domain, is that when you do your development and you move your code from test environment to QA to prod environment, you have all different servers which all have different names, test 1, test 2, blah, blah, blah. So you don't, developers are lazy, sometimes you don't want to specify a different configuration or servers are merged. So you just put a star and say, every server can access this information, fine. And then this configuration goes to production. Boom, you have a problem, right? So, be mindful when you put stuff into production, specify the correct origin. There are also other headers that can help you. For example, access control max age. This one specifies for the time frame for which this request is granted. So if you send your first request from, say, www.example.com, and it says max age, 24 hours, then for 24 hours you don't check if example.com is allowed. And then if you make a configuration change on your server, then it will check again after 24 hours. So make sure that this time frame is not 3 months. And it's very simple to configure. Like in iOS 7, you just write a couple lines in web config. In Apache, you use mod headers. You say, header set access control allow origin, and you specify the list of domains. So a couple lines of code makes your application protected. Where CORS can help as well. So first, when you do the requests across origins, but even if you do requests in the same origin, you can use CORS to protect from cross-site request forgery. So for example, I have mybank.com, and I have the transfer page that gives, classic example, that transfer money from one account to another account. And you use the CSRF to transfer money from a victim to your account, right? This request, because the victim visits a malicious website, and the request is sent from the malicious website, the origin will be not mybank.com, but some other, attackerdomain.com. So if you have the CORS policy set, which is only allows to mybank.com, then if request comes from attacker, it's not going to be granted. Even without the CSRF token, without anything, it's not going to be granted. So that's good, you can use it, but remember that you have this setting for the whole website. So if you have mybank.com, which also should give some information to other websites, say some stocks.com or something else, if you say that only mybank.com requests will be granted, then you have a problem. So you cannot configure it per path so that you can use it on the transfers page, but cannot use it somewhere else. So.
It's just for response or request as well?
Well, for
CORS policy.
For response for the requests, right? So post and get. So if another web server sends a request and it comes from a different domain, you get the response with an access control allow origin with a different domain, and then your browser actually checks that, okay, the request came from a domain that's not in the list, so your browser will not render it.
Yeah, that's fine. It will not render. You're talking that if CSRF tokens are not there.
Yeah.
But still, I'll get the request to the server. So my request would be actually served at the backend. Though I will not get the response, but my request would be served.
Yeah, your server will get the request.
Yep, and it will be, I guess, processed.
Processed. If it will be a process.
It's actually a rogue application in that case.
Huh?
This is a rogue request in that case.
Yeah, I understand. So you have the header served set on the server, right?
Okay.
So it will not go to the application, because on the server level, it will say, okay, the request came not from where it came, so it will stay on the server level, the web server level, and it's not going to go to the application. It's not going to be processed.
It will not be processed on the server as well?
Not in your application. But the server will get response, get request or post request, and respond with the 200 OK and some data. But this data will come just from the web server, not from your application.
Okay.
So I mean, if the header is different, the response will be the body will be empty. It will just send 200 OK and some headers. Yeah, so it's not going to process anything. Yep. So I'll move to the next technology, web messaging API. This is also created to do some cross-origin messaging, but this is a little bit different. It's not between the different servers. It is between the different objects on your page. So you have a page loaded in your web server, in your browser, and then you have some iframes. You can, create a pop-up window. So all these objects can now communicate between each other. Before, same origin policy prohibits doing that. There are some ways to kind of work around. You can use the frame identifier messaging, fragment identifier messaging. You can use window.name, but these are where all like hacks how to get around this. So HTML5 provides a real technology with some restrictions that allows you to send messages across domain. For example, you have your parent page, and then you have an iframe from a different domain. So you can send stuff back and forth. So who can send messages? As I said, frames, iframes, parent window. Why? Because you are using JavaScript for that. So you have to have a handle, a JavaScript handle. So JavaScript object to which you post a method or which sends the response. So anything you can access through JavaScript on this page. That means you cannot send a message to a different tab or somewhere else in a different browser because you cannot get the JavaScript handle.
Is it both ways, parent to child and child to parent?
Yep. So there are two APIs. There is the post message. The sender says, get the iframe1 dot post message, sends the message, which is a text string, and then the target will be the URL that receives the message of the receiver. And then on the receiver side, say in the parent document, you add an event listener to this message, and then when this message comes, it processes the message, right? And so what is sent in the message? As I said, the message itself, which is just a string, text data. The origin is where the message came from, so the URL, not the full URL, but what's the origin, so the schema, the domain, the port, the origin, and the source is the JavaScript object that sent the name, that sent the message. So if you have a parent document and it's listening to a function, it receives the function, and then it says, it receives the message and it says event.source, it will get the JavaScript object, JavaScript link to the source that sent the message. So this way you can send a response. So you get event.source .post message and send something else in the response. How is it vulnerable? What can we attack here? We can attack text data if it's not validated, the text that's sent, and we can attack the origin. So if the parent page is waiting for a message from iframe1, iframe2 can actually send a message and the parent page will still process it. So if you have your website and you have some iframe that is has some legitimate content, and then you have some advertisement in another iframe which you don't trust, the advertisement can also send some information to your parent page. So let's see how it works. So here I have a parent page with two iframes, very simple. There is one is safe domain, another one is attacker domain. So we are expecting some data from the savedomain.com, and what we're expecting is some number, some probability number, right? So we send it with message, and the probability is updated. So we're sending some number, and this number is embedded into the DOM of the parent document, into the page. So if attacker sends some data, it is also embedded. See, there is no checks on that, and actually you can see that this is a link. So we hover over the link, and boom, we have cross-site scripting executed. So that's one problem. And we can see here in the console, because in the source I'm outputting which origin the message came from. You can see, I think it's pretty readable. So the first one came from savedomain.com, and another one came from attacker.com. It was still processed. Let's look at the code and see how we can protect that. So here is the lotteryoracle.html, the parent page. We have the receiver function, so we have the event handler added here, and then we add this message and the receiver function. So inside the receiver function, as I said, we output to the log, just some testing, and what we do is we get the percent element, and we just say event.data. So we get that text data, and we just dump it into the inner HTML property of the percent. So we just write it out. So there are two problems with that. First, we don't check the event.origin, right? So we can change that, and that's what we should do. We should check where the message is coming from. So we add this simple string here, and we say if event.origin is not equal save domain, just return. Don't do anything. Okay. So we refresh that. And try to send message from attacker.com, see, nothing happens. We output the domain, but the value is not changed. So we protect it from data being sent from a different domain. Now, the other thing that we should check is the data format. So if our trusted domain gets compromised and it starts sending some data that we don't expect, it can also send some JavaScript, some bad data. There we go, send bad message and JavaScript is executed. So what can we do here? As you can see, we are just getting the event data and putting that into inner HTML. So we don't check it, and because we are putting that into inner HTML, the inner HTML property of JavaScript executes everything that's inside, and if you put some script in there, it will execute it. So instead of using inner HTML, you can use content text. That's another property which is similar to that, but it says that whatever you input into this property is not HTML, it's just pure text. So let's try that. We update, we send a good message, it works, we didn't break our code. And then if we send bad message, it gets embedded just as text. And if we look at the source, then we have
You need to
yeah,
related source.
we look at here. Yep, so you can see that this is actually this one. There we go. So you can see that our message is encoded. So instead of the less than, we have HTML encoding. And this is a wonderful thing because the text content property does HTML encoding natively. So you don't need to write any of your own encoding things because writing your own encoding can be difficult. You can miss some characters, can be still broken. So using native HTML encoding is much better. Another thing is that maybe you don't want your users to see that string. I mean, users are like, what? Image, blah, blah, blah. So what you should do, you should check your data. And that's another step. So instead of just putting the event.data over here, because we know that what we are expecting is a number, so we can do that. We can create a variable and do some regex saying that, okay, is this a number? If yep, that's a number, then output the number. So in this case, there's that. If we send a good message, everything works. If we send a bad message, it just doesn't process. So perfect input validation works. Okay, and let's move to the next one. So yeah, as I said, to do web messaging securely, you must check two things: check the origin and check the data. Validate the data and also use the text content for output encoding. Let's talk about web storage. That's another new thing that was introduced in HTML5. And now there are two objects. They first introduced 4 of them. There was also SQL storage and global storage, and now local storage and session storage are used more widely and supported by almost all of the browsers, the latest versions. So local storage, data that you store in the local storage, it's a JavaScript object, and the data is stored indefinitely until you clear it with JavaScript, or you go to your browser and say, clear history, and then that's when you clear it. If you don't do it, it's there. Session storage was intended to be the same, to work for the same time as the server session, but actually it stores data while your tab is open. So you go to a website, log in, some data is stored in the session storage, you click log out, your session on the server is invalidated, but everything is still in your browser. So until you physically close your browser or you close the tab, the data is there. Also, if you open a website, you log in, and then you open a couple more tabs, different links from the same website, you log out in one of the tabs and close it, in the other ones, it's still there. So if you store some sensitive information, think about it. Don't store it for a long time. So issues that we have with web storage is client-side trust. As with anything we store on the client, don't trust it, because first, anything you store in the client can be read by the client, and or which means can be read by the attacker, because we don't control the computer of the client. You can read it by physically accessing it, or malware, anything. And when you read data from the client, also don't trust it, because it could be forged, it could have been changed, because everybody has access. That's what we should think about as security professionals. Another problem with the web storage is cross-directory attacks. So web storage is regulated by the same origin policy, just like everything else in HTML, almost everything else. So the same origin policy only regulates it by the origin. And as I said, origin is the schema, the domain name, and the port. Not specified here, but of course it's port 80. So if you have two applications that are hosted on the same domain, but on different paths, they both can read information stored by each other. So if John Newman stores something in the local storage, that means that Ada Lovelace application can also read that local storage and modify local storage. So if you have a website that has the same domain and different applications, just the advice would be do not use local storage. Just use JavaScript variables, something else.
What about HTTP and HTTPS?
Different port.
Yep, different port
So
and different protocol.
The different protocol, that means different origin. That means they cannot read each other. So that's good. That's protected. So how do we protect it? First, if you need to store some sensitive data, something about the session, sometimes you do need it, to pass between the different pages. Use session storage. Don't use local storage. If you store something in the local storage, only store some information that has no security value, no control. So you can store things like user preferences, if user can change the layout of website, choose favorite picture. Yeah, you can use all that stuff in the local storage if you want to store it on the client. And the other thing is clear the storage, session storage, after you have used it. Because, as I said, even if the user logs out of the application, the information can still be there. So once you read the information, so you set some information, then you read some username information, and then you say, session storage clear. You physically clear the session. Interestingly enough, just today I read an article on the internet that there was another vulnerability discovered with local storage and session storage. By the browser implementations, they set a certain space limit on how much information each website can store. And I think Chrome has like 5 megabytes, Opera has 7 megabytes, and IE allows 10 megabytes. It is controlled by the domain, by the origin, but it's not specified for the subdomain. So if you have your website, which can store, say, 5 megabytes, and then you create multiple subdomains and store some other information, you can just eat up the space on the client's computer. I mean, it's not a huge security problem, but still it is. So that means that technology is new, it's not completely tested. There can be some things interesting, so be aware of it. And so now we'll move to the next, I think that's the last technology that I'm going to be talking about today, is sandbox attribute. So HTML5 introduced this sandbox attribute for iframes. Before that, if we have an iframe, same origin policy works for it, and that's what controls it. So if we have this iframe embedded in the parent document, then if it comes from an untrusted website, it cannot read the DOM of the document. However, it can execute scripts, it can execute plugins, it can submit forms. What it cannot do, it cannot read the data from the parent document and modify the data. So the guys who created HTML5 thought, well, we can get some more fine-grained control on that. And they created this sandbox attribute. So with the sandbox attribute, you can set several values for it. First, you can set it to an empty string, and that's the best one, which says no trust. don't trust anything that comes from this iframe. Don't run scripts, don't get access to the DOM, don't submit forms, don't execute plugins. Basically, this iframe can only display some static content, and that's it. It can't even run Flash, or Silverlight or something like that. Then another one, so that's the most secure. That's what you should use if you know that the iframe doesn't need JavaScript to properly execute stuff. Okay. So the other ones are allow same origin, which means give all the control. Tell the web browser that this iframe that comes from a third-party malicious domain is from the same iframe that the parent document. So it can do anything: read DOM, modify DOM, send data, send forms, anything. You can also set it to allow top navigation. That means it can change the parent's document's URL. You can allow forms and allow scripts. So if you set just allow forms, it can submit the forms, but it still cannot access the DOM. If you say allow scripts, again, it cannot access the DOM, but it can run some JavaScript and do some internal processing. But think about it, if you allow scripts, for example, that means that JavaScript can actually submit forms as well. Not physically, but you can say form.submit and send the data. So as the most secure one is, sandbox, empty string. Why this is important? On one hand, yep, that's perfect, fine-grained, controlled thing. On the other hand, sandboxing allows to break the protection from clickjacking attacks. So this is very interesting. I find it interesting. Because this is some new technology that is supposed to make HTML more secure, but it helps hackers. So what happens here? Clickjacking, if you're not familiar with that, what happens is the attacker gets the vulnerable website, embeds it into an iframe, and there are two different versions. In one version, the top iframe, the victim iframe, is invisible, makes it visibility to 0, and then the underlying iframe, the attacker page is visible. So the user goes to this web page, and the victim website has a one-click functionality. For example, like in Amazon, if you're logged in, you can do a one-click purchase, or you can click on some commercial, and the commercial will get the clicks. So the attacker makes his page look like some game, and you just move your mouse and make clicks. And at the same time, the victim application is located so that you actually click on the invisible top layer on the victim application. So the user thinks that he's playing a game where actually he's buying stuff from Amazon. This is one type of clickjacking. Another type of clickjacking is vice versa, where the victim page is visible and it's on the bottom. Attacker page is invisible and it's on the top. So in this case, for example, the victim page is some banking, login page, and then the attacker page overlays it so that the attacker's controls are right over the login and password controls. So when the user types his username and password, he thinks that he's typing something onto the normal website, while he's actually typing his username and password onto the invisible attacker frame, and attacker steals the credentials. So that's basics. For both of these clickjacking attacks, what you need is you need to put the victim website into the iframe. And protection from that is what's called frame busting code. So that's very simple frame busting code. The website checks if I'm the top, which means if I'm the parent document. If I'm not the parent document, actually make the top location of the parent document my location. So basically reload the attacker's page and make it my bank.com. So if we use something like that, sandbox equals empty string, that means that iframe cannot execute any JavaScript, and that JavaScript will just not be executed. So the page is not protected. So let's see how it works.
But I guess that frame busting can be bypassed, that basic frame busting.
Yeah, so that's what the demo is about.
Okay.
So the way how technology develops is attackers come with make up some attack, developers make some protection, and then attackers like, we can bypass that in this way, and then developers like, oh, we can protect it by this way. So I just want to show how that works. So this page, oops, there we go. This page doesn't have any protection from frame busting, from clickjacking. So I have another page, attacker from attacker.com, which can put the banking page into an iframe. So we want to protect that. So in the online bank, we're gonna add some frame busting code. That's the one that I showed in the presentation. So we add that, and we date. So we can check that that's not breaking our application. Our bank still works. Everything is fine. And then here, if we refresh the attacker page, you can see that we were redirected to savedomain.com because we checked if it's not top, go. You can also put a breakpoint here. Okay, so I'm going to do it because I cannot see. So now, in the attacker page, we say, let's add the sandbox attribute so that this JavaScript is not executed. So I have the same attacker page, which has an iframe, and it has iframe sandbox set to an empty string. So now we load that attacker with the sandbox. And so we can see that JavaScript doesn't work. We can still embed that into an iframe. So what we can do is we can have frame busting code, which is not dependent on JavaScript. We can also use CSS for that. That's a different type of frame busting protection. So what happens in this code here is we first specify the style attribute, and we say that the HTML object should display nothing by default at the very beginning. So no, if JavaScript doesn't work, just don't display anything. Then we say, okay, if JavaScript works, if this script executes, again, check. If self equals top, if I'm the top element, then yep, set display style to block, which means display everything as normal. And then if self is not equal top, then navigate the parent page to my page. So same as in the previous. So if we load that in the page that has the sandboxing sent to an empty string, so we load an empty page because JavaScript is not executed, but we have set the CSS style to display none. So attacker will not be able to do click checking because the victim page will just not display anything. So obviously you cannot trick the user. So that's an interesting thing. How
is it not just displaying, or it's not even present over there?
It's not even rendering it.
Okay, it's not.
So it's not like the controls are there, but they're invisible.
Okay.
The page is empty. If we try to select that, maybe. So, well, I mean it's not loaded. It's not there. So you cannot trick the user. You cannot change the style to something else and then have it executed. Well, and that's it. And we have 5 minutes for questions.
What is the default value if you want to specify sandbox attribute?
Excellent question. If we don't specify, so the question was, what is the default value for the sandbox attribute? The answer is there is no default value in terms of HTML5. If you don't specify the sandbox attribute, we go back to HTML4 or whatever, which means we go back to same origin policy. So if you don't specify it, if the domain is loaded from a different, if the iframe is loaded from a different domain, it cannot execute scripts. It can execute scripts, but it cannot get access to the DOM.
When we know that there are so many issues with cross-domain calls, why do you think it is allowed?
Why it is allowed?
Yeah.
Well, if you use it properly, if you set it properly, then you don't have issues. I mean,
But I can use this feature to make rogue applications, like cross tabbing. I can send requests to the other tab applications and all.
So with the course, you cannot send application request to another tab. You can send it to another server.
No, what I'm saying is like, for example, I have a Gmail open on one tab.
Uh-huh.
I have a root application.
Yep.
I can send cross-domain calls to the Gmail, to Gmail.
Yep.
So same session ID will be taken over. So I can get a request from there. Essentially, I'm doing a cross-domain call here.
So you have your Gmail in one tab, and then you have a rogue application in another tab, and you're saying, I can send a request from the rogue application to Gmail, right?
Yeah. Not on the tab, but the server.
To the server, to the
Yeah,
Gmail
so
server.
Same session ID which is in the other tab will be carried forward.
Yes, exactly. But that's you go to CSRF, right?
Yeah.
So you send the request. If there is no CSRF token, then yes, your cookie is sent with the request. You're right.
Not even
And it will-
CSRF, just to get general content. Like I just send a request to index page will be rendered to me. Now with the cross-domain calls, I have much more control on the response what I'm getting.
Mhm.
Like that.
Yep. So
So I can use it for a root purpose.
But
use it
for that, Gmail also allow that rogue application to render the content.
So Gmail doesn't understand from which tab it is coming, right? As long as
But
the session ID is valid.
yes, it understands. It even though you send the cookies, it has the origin call the header called origin, and the origin will still say rogue.com. So the origin header, that's what they edit in the course. It says where it came from. So we have the refer header, which can be spoofed sometimes. So origin is kind of a replacement. So if you have course enabled, then yes, with the origin header will say it comes from malicious domain, and then Gmail can check where it came from. So even though you have the cookies in the request, yeah. Any other questions, discussions?
You talked about the post message, right? Post
Uh-huh.
message from one domain to another domain actually. So is this supported in all kinds of browsers? I know that IE does not support that.
Yeah, so it is supported in the latest. I know it's supported in Chrome, in Firefox, and Opera. IE, I should check. Maybe in IE10 they support it. I mean, it's HTML5 is still new, so you're right. When you make a choice of using HTML5 in your web application, you should think about your user base, which browsers they use. If they still use IE7, then you should use something else. I mean,
So
it's not gonna work.
if my user base supports like all kinds of browsers, even the lower version of Internet Explorer. So do you think that I should be developing HTML5 at this point?
Well, I would get the calculation of if you have 5% of your users using IE6, then yes, because 95% of your users use the newest browser, and then you always can do a check of which version of the browser they're running and say, hey, you're running an old version. This application can only run in IE8 or 9 or whatever. I mean, it's management decision. It's not as more of a developer decision. So I know a lot of banks that do support all the browsers. They don't use new technologies. They make a very mild transitions to the new technologies. They stay with the older versions of applications.
Okay, so in HTML5, you talk about sandbox where you can sandbox an entire frame so that it does not access the parent domain or some other frame actually, right? So in the previous HTML4 or below, right? So how can I achieve the same thing?
So in HTML4, if the iframe comes from a different domain, it cannot access the parent. Oh, yeah, the parent message. So there are kind of workarounds how you can do it. One thing is called fragment identifier messaging. So the fragment is the little piece in the URL that comes after the hash, where you have your document, Wikipedia, blah blah blah, hash, and then the name of the article, right? So in both the parent document and the iframe can access the hash. So the iframe can write something into this hash, and then the parent document can read something from this hash. So it's kind of a, some location that both the iframe and the parent document can read and write to, and that's where they can kind of leave a message, and then, but there is no, on the message action. So your parent document should check the hash, say, every 5 seconds or something. And then it also doesn't know who wrote to this hash. If you have two iframes, they both can write to this hash, so you don't know where the message came from. So some frameworks, I think, if I'm not mistaken, Dojo is using frame identifier messaging for their, for their JavaScripts. Yeah, it's not secure, but it's possible.
Other than the cross-domain, picture. What else you think can go wrong with HTML5 applications?
What else
Can go wrong? What
can go wrong? Oh, a lot of things. So on my first slide, I talked. Shh. So in my first slide, I said that I'm talking only about 4 things, right? There are much more technologies, and many of them have their vulnerabilities. Say WebSockets, right? They allow to set up a socket and send any information between the 2 different domains, which means this information doesn't go through HTTP. It goes through TCP level. So no same origin policy works there. So if you have a script that sets up a HTTP WebSocket with your server, maybe some malicious iframe can set up another socket with a malicious domain, and if it can access information from your page, it can send some messages under HTTP. And if you have some WAF firewalls or something, it's not going to catch it because it's on the TCP level. Geolocation, it has a lot of privacy issues. It's not vulnerable in the sense that you can exploit something, but if you get the geolocation of where the person is right now, yeah, you can do stuff. If you know that right now he is in Starbucks, where there is a Wi-Fi connection that's not secured, you can go to the Starbucks and spoof some information. You should always think about when you use something new like HTML5, you use new technology, think about security implications that come with it. Do some research, think like an attacker, how you can exploit it.
Thanks, Amy.
Thank you.
Thank you.